just basically saw consensus mechanism is just a methodology that we have to see that everybody in the network agrees to a particular convention or a particular rule or whatsoever. So that is why we have something called as consensus in the blockchain. So because since we are actually dealing with a decentralized environment, a totally distributed environment where transparency and security is of utmost concern, we should see that you need to establish something called as trust amongst all the the peers in the network. So to do this, we must have some certain kind of rules designed, some protocols needs to be there in place, which should be followed by all the people. Only then the entire network can be successful. It can move forward. So that is why we are going into this concept of consensus. That's what we saw. And I think we briefly went through the various important properties or objectives or goals or whatever you want to call it. All these goals we had just briefly seen, like there should be a unified agreement. You must everything should align to a proper incentive. It needs to be fair and equitable. Fair and equitable property is also called as the egalitarian property. Okay, so it has to be egalitarian, and then double spending needs to be prevented. Fault tolerance must be there. So all these, all any protocol which is satisfying all these properties can be implemented on a decentralized distributed network. Okay, so and we briefly also went into this problem called as the Byzantine's general problem, right? Where these people had an issue of capturing a castle, and then and if there is some kind of miscommunication which takes place between these people, then the entire what do you say? The entire idea is going to kind of collapse. Okay, the result is not going to be successful if any one of these become traitors. So this is what can happen when we are working on a distributed network. So this was another one problem that we basically saw. So all these issues has to be removed. So we are introducing something called as consensus. So in the blockchain network, we have different types of consensus protocols that are implemented. Every network follows a different consensus protocol. Okay, so we're just going to discuss what all those protocols are. Briefly, I've covered them in the introductory part, but we're just going to see them a little bit in detail here. Okay. Okay, this is again about now coming to the first very common consensus protocol, which is called as your proof of work. Okay, so this is the protocol which is basically implemented, of course, in your Bitcoin blockchain. Okay, all right. So again, just trying to kind of refresh to you about the structure of a block. Okay, this is what it basically will contain. We know that it has data, which is nothing but the various transactions, right? I'm talking about the Bitcoin blockchain only. So we are only talking about transactions here. So we have a set of transactions which will be stored. Okay, it can go to around say 5 to 500 different transactions you can have in a block based on the size of the block. We also have something called as the previous hash, which is the previous block's address. And we have the hash address of the current block. So all these details is what go into a block. We already know that, right? So basically I told you these consensus mechanisms exist to ensure that every transaction that is stored in your block is authentic. It is valid. Now, for example, like supposing say A is transferring to B, say like four bitcoins are being transferred by A to B. There should be some proper mechanism to see that this 4 doesn't become 40 at any point of time. There should not be any intruder who is able to kind of tamper the transaction, change the value, change the sender or change the receiver or do all sorts of things. And these things are actually possible. So such kind of, what do you say, malicious factors should not exist on a blockchain network. Right? So that is why we are coming onto this proof of work kind of a consensus. So proof of work is basically applied on different blockchain networks like your Bitcoin. Bitcoin uses proof of work. Then Ethereum also uses proof of work. Currently it is using proof of work, a part of it. Then Ripple is another network which uses proof of work. We also have Hyperledger, which also uses proof of work. Okay, so different networks. There are plenty of blockchain networks functioning for various uses. Now, the Bitcoin blockchain network we are learning because it deals with the cryptocurrency exchanges, which is typically Bitcoins. So we are concerned about how proof of work works on a Bitcoin network. So we know that, and initially, when I briefly explained to you about proof of work, a proof of work is nothing but a puzzle solving mechanism. There is a puzzle which needs to be solved. This was what we initially saw when we were learning about proof of work, which means that now I have my previous hash is there. Okay, I have the previous hash and I have also generated the block hash. Okay, now these two values I have with me. Now, along with these values, what I will be adding is I will be adding a number which is called as nonce. Okay, and this entire thing I am going to hash using the 256, SHA-256 algorithm. After I hash this, this value should be equal to something called as my target hash. Okay, so this target hash is also a hash value which has got a certain number of zeros, leading zeros. Okay, it has a certain number of leading zeros. So it has got something like this, C, H, etc., etc., etc. It goes. Okay, so after I am applying my hash algorithm to all these values, I should be able to get a target hash which is already defined in my network. The moment I achieve this target hash, then my block will be added to the blockchain. This is the entire concept that happens in proof of work. Okay, so the entire functioning depends on generating the nonce. This nonce is a number. It's actually called a number. What was anybody who can tell me the expansion of nonce? What is nonce? Number? I remember telling you sometime introductory part of it. Nonce is a number which is yes. Hello.
Number only used once.
Yes, which is a number used only once. Okay, this is what is basically called as a nonce. So nonce is a number which you have to actually identify. Okay, there are 4 billion nonces that exist. Okay, so which means it is from 0 to roughly this number. Okay, this is 4 billion something, 42949 67296. It is a number between 0 and this. Okay, so any one of these numbers between this you will have to keep generating, so that after you find the hash of this entire thing, you should be able to get this target hash. So this is the computation that is required to be done in your proof of work algorithm. Fine. Now this hash that we say, right? This hash that is there. Now this is the target hash which you have to find out. Now hash is this is all these are hashes. Okay. A hash is basically a 64 digit hexadecimal number. Okay, these are all general concepts. Please listen a little carefully. A hash is a 64-digit hexadecimal number. Matlab, you have 64 different digits, and each of this is a hexadecimal number. So how much is a hex? How many values does a hex contain? Now, supposing like this is my hash. Like say I'll take this hash only. I have 4 zeros, and then I have a DF, then I have a 2E, and then I have a 5-7, and etc. 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 64 digits will be there. Clear? So how much is each of these digits? Each of this is a hexadecimal number, right? So how much is this digits? How many digits will I have here? How much digits will be 0? This 0, how much digits will this be? How much digits will D be? How much digits will it have? How many places?
6.
Sorry? 6. Hexadecimal. How much is a hexadecimal number, guys? Please. Don't make me teach you all concepts here. What are your hex codes? What are your hex codes? Aren't they like this? Yes? Forgotten? Are these your hex codes? Right? So how many digits do they make? Totally? How much digits do they make? One hex code is how many digits?
16, ma'am.
Yes. Don't take so long to answer these. These are what do you say? These are basics which you should be learning in school also, right? Hex codes 0 to 9 and A to F, right? Totally 16 digits make a hexadecimal number. Fine. So this 0 that we have is a 16 digit number. This 0 again is a 16 digit number. Now this D again if you take is another 16 digit number. The 7 if you take here, this again is going to be a 16 digit number, right? So I have 16 digit numbers which are being repeated 64 times. So totally I can have this many possible values. Yes? Yes or no? Is this possible? Totally, you should be having 16 raised to 64 possible values are available. So this many possible target hashes exist. Okay, so the target hash could be anything between 0 to this 16 raised to 64. Whatever this value is going to be very, very large. Okay, which cannot be expanded here. Fine. So the target hash could be any one value between this to this, which is generated by the network. And the target hash that has been created, this is the target hash which I'm talking about, right? Which you have to calculate, which is being mined by the miners. So this target hash is decided based on the number of miners that we have in the network. Okay, if you have a large number of miners in the network, then your target hash will have more number of zeros in the beginning. Your leading zeros will be very, very large. So when you are increasing the leading zeros, it means your mining efficiency is kind of going to increase. It means it is more difficult for you to kind of guess your target hash if you have large number of zeros in the beginning. Okay, if you have very fewer zeros in between, supposing my target hash has got only, say here in this case, for example, we'll assume this to be the target hash. My target hash has got only 4 zeros in the beginning. It means it's going to be much more easier for me to guess. Matlab, I'll be able to guess the hash in a quicker, in a much more faster manner. Okay, I'll take me lesser time to kind of guess my hash. Guess my hash. So if the leading number of zeros is very big, then I'm going to take more time to guess it. If the leading number of zeros is very small, I can guess my hash very, very fast. Okay, so this target hash is decided by the network. There are algorithms which kind of decide what is going to be the target hash based on how many miners are there in the network. So if the number of miners are very, very large, then suppose I'll just write that here. If your miners are very large in number, in that case, it means that your target hash will have more number of zeros. Okay, and it's just the opposite. If your miners are very smaller in number, this will have lesser number of zeros. This is the logic that is followed when this the target hash is being generated, and this process we will call as hash rate. The hash rate is decided based on the number of miners on the network. Or in other words, you can say the hash rate is the aggregate computational power of all the miners in the network. That is what we call as the hash rate. So based on the hash rate, we are going to decide your target hash. If your hash rate is going to be very large, which means the miners are large, then more number of zeros. If the hash rate is going to be small, it is going to have lesser number of zeros. You understand this general concept of how your proof of work kind of works? Any doubts here so far? Any doubts here, guys? Shall I continue?
Yes, ma'am.
Okay. So this is it. Now, I told you this nonce that we have is one amongst these 4 billion values, right? This nonce. This is something that you have to predict. You have to keep guessing. Remember, whenever I just telling you about this, we were just kind of playing a game of like I thinking of a number between 1 to 100, and I asked you to kind of guess how many guesses you can make. So that's exactly what we are doing. So I'm going to think of a number between 0 to this much 4 billion, and you have to guess what is the right number so that I will get my target hash. Fine. So generally, any mining device we saw, there are several mining devices, right? We have a lot of application-specific ICs which help in doing this mining process. So any mining device can basically create only 1,000 million hashes per second. Okay, 1,000 million hashes per second. So now, if you need to be creating around 4,000 million hashes, you require at least 40 seconds. If you need to be creating 4,000 million hashes, clear, which is nothing but your 4 billion. So if you want to create a if you want to find out the correct nonce, you will be able to find the correct nonce in 40 seconds. This is the mining power. Provided you have a mining machine, you have an ASIC, which will be able to generate this many nonces per second. 100,000 million nonces it should be able to generate per second. Only in that case, you will be able to find the correct nonce in 40 seconds. But still, it is not very easy. I'll tell you why it is not easy. I just need to do a little bit of erasing here. Okay. Okay. So I'll tell you why guessing the nonce also is not going to be a very easy process, because now I told you to kind of solve this entire process. I have the previous hash, okay, previous hash plus the current block hash plus nonce, right? All these three is what is going to be hashed. But now, along with all these details, we know that the block header that we have also has one header, one component, in other words, which is called as my timestamp. Remember what this is, what the timestamp means? What does the timestamp store? Timestamp in your block header, what does it store?
Time when the transaction occurred.
Yes, the time when the transaction occurred. It's basically the time which has elapsed from 1st Jan 1970. The amount of seconds, the amount of time in seconds that has passed from 1st Jan 1970. This is a standard fixed date which was decided. So the amount of seconds elapsed from this date, that is what is stored in the timestamp, which basically means the time on which that particular block was created. Okay, so we also have this timestamp. Now this timestamp also has to be added along with this generation. And remember, mind you, this timestamp is something which will keep changing every second. Okay, every second the timestamp will keep on increasing. Fine. So now supposing now say this is a fifth second. Okay. Say this is my timestamp stores the value of 5. Now I have to hash this entire thing with one nonce value. Okay, a nonce value I have to try, and the fifth second I'm trying all the nonce values between 1 to 5 billion. I get something which is equal to my target hash. Assume I got my target hash. Okay, but by the time my target hash has happened, my timestamp would have become around say 10 seconds. So which means my when I am doing a hashing of this entire thing, again, it is not going to be equal to my target hash because my timestamp would have elapsed. Because for me to generate a nonce, I told you it will take you at the maximum of 40 seconds to generate my nonce, correct nonce. By the time 40 seconds have passed, my timestamp also would have got ahead by 40 seconds. So generating the nonces in 1 second, in other words, you have to go into fractions of seconds, in 1 millisecond, in 1 microsecond, I should be able to generate all the 4 billion nonces. So you must have not just a very simple mining machine. You should be able to have a mining farm. Only if you have a large mining farm will you be able to kind of find out nonsense in the fraction of milliseconds and microseconds. Only then you will be able to identify the target hash and you will be the block winner and you will be able to kind of add the block onto the blockchain. Why? Because since the timestamp is another factor that is added, the timestamp every second keeps on changing. So you cannot afford to wait for 40 seconds to kind of find your nonce. It is going to be very, very long. So you must have such highly, you should be equipped with so much of ASICs so that your nonces, the amount of nonces that you generate is going to be in fractions of microseconds. Only then you will be a successful miner on if you are using the proof of work consensus. Clear? So that is why making working on a proof of work consensus is very, very difficult. Why? Because you require a lot of mining power. I told you about ASICs, the amount of noise it generates and the amount of cost that is incurred for purchasing one single ASIC. It is going to go run into lakhs for you. So if you want to have around 10 to 20 ASICs, that much amount of investment you will have to make, okay, to kind of become a successful miner. So that is why we basically individuals don't go into proof of work mining. They don't become miners. Only you have separate companies which do this mining process. They can who can afford to kind of invest that much amount of money, create a mining farm. You must have a mining farm, a place where you can have all your ASICs set up, which will keep on generating your nonces. Okay. So now supposing another option that the miners have is if you are not able to find the target hash, what these miners will do is they may even change the transactions. They will go to the memory pool and change the entire transactions. They will choose a new set of transactions and also they will add it into the block. This also is another option. If they are continuously mining and they are not able to kind of find the correct hash with all these values, what they will do is they will change the entire transactions, or if not the entire transactions, one or two transactions they will pull out and replace it with some new transactions from the memory pool. This also there are a lot of permutations and combinations that these people can do until they find the correct target hash. Okay, so this is about the entire concept of proof of work. Fine. So yeah, this is just nothing. So this is what I'm trying to tell you. These are all the possible hash values that can exist. Okay. So your target hash, as I told you, it is anything between 0 to 16 raised to 64. This many target hash values are available. Okay. Out of that, only one is going to be right. Only one is going to be the correct target hash value. All right. So yes, this timestamp. So this is the timestamp will look like this. There's also a number which looks like this. The amount of the number of seconds that has elapsed from 1st Jan 1970. Okay. So and for this block, this is the nonce which was generated and it was kind of added. So this is how it is done. And as I told you, supposing the miner wishes, he can also replace the transaction. So he may kind of pull out some transactions from the blockchain, take some more transactions from the memory pool and add it. That also is an option which the miners can kind of do in order to guess the correct nonce. He has his option to do it. Okay. Okay. So that is about proof of work. Fine. Now moving to the next algorithm, which is called as your proof of stake, which is much, much simpler than your proof of work. So proof of stake is generally called as your virtual mining system. Okay. a virtual mining system which does not require that much of computational effort as that of proof of work. Okay. Now Ethereum, I told you initially, was doing proof of work. Now this blockchain is moving from proof of work to proof of stake. Almost 90% of the network has migrated from proof of work to proof of stake because proof of stake is much more, a lot more cheaper, and energy consumption is much more less when compared to that of proof of work. So here we don't have miners, we will call them as validators. In proof of work, we had miners, here we have validators. And in proof of work, we were mining the blocks, here we mint the blocks, or in other words, we forge the blocks. Okay, we either mint or we forge the blocks. Okay, so what happens? Just a minute. हेलो यस हाँ बोलिए 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 हाँ हाँ कब तक ओके थैंक यू yeah. So what happens here? Here also we're going to have multiple validators. Okay, there'll be a lot of validators in the network, like how we had miners. Here we are going to have a lot of people who are doing who are going to forge blocks. Okay, so we call them as validators. So a lot of validators will be there. Amongst all these validators, one person will be chosen. The one validator will be chosen who has got the highest stake. That's why it is called as proof of stake. So what happens is, now supposing this is, say this is a validator called Bob, okay, and this is a validator called, say, David. Okay, so what these people, what all the validators, what they have to do is they have to invest a certain amount of cryptocurrency. Okay, whatever blockchain you are in, every blockchain follows a particular cryptocurrency. Now Bitcoin follows, it follows the BTC currency, right? Ethereum follows another currency called as ETH. Okay, Ether it is called. So since we are talking about the Ethereum blockchain here, we will talk about ethers. Okay, so what these validate, ether is also a cryptocurrency that we have. It has also got a value, like how one Bitcoin is equal to 3.5 lakhs or whatsoever. Ether is also roughly equal to some 1.4 lakhs or whatsoever. Okay, so all these validators in the network have to invest a certain amount of ethers, which means that now say David is going to invest around 100 ethers. He's going to lock up 100 ethers and keep. Okay, so 100 ethers is going to be locked up by David. Now Bob will say is going to lock up around 1000 ethers. Okay, now each of these validators like that, each of them will be investing a certain amount of ethers in the network, which will be blocked. They cannot be using it, they cannot be spending it. It's just going to be locked up in a chest or in a treasure. They're going to lock it up in a treasure. Okay, and the person who has taken the highest value, that person is given the opportunity to add the block. Okay, this is what happens in proof of stake. So there's not much of there's no what do you say, you don't have to spend a lot of effort on computing something, finding out something, and then only if you're successful you will be able to add a block. There's nothing like that. If you have enough number of ethers to deposit and keep them safely in a particular treasure, then you are eligible to kind of add a block. So now in this case, since this person Bob has got he has invested a large number of ethers, then this person can add a block. Okay, so now what is anybody who can tell me what is the drawback of this method? What happens in this kind of a network? What can happen?
Same amount.
Same amount where? Which amount gets is the same?
If David and Bob invested same amount.
Okay, that's one option. Okay, so it may then this it cannot be decided. Somebody has to invest more. Either of these people, anybody has to invest something more. Only then they will get the opportunity. There's no point in having same amount. Okay, that is one issue. Fine. Any other drawback? Now, supposing say now all these people say are investing only this much. Okay, 10, this guy 20, this guy 40, this guy 50. Now Bob has got an opportunity. He's added the block. Now this cycle is over. The next cycle, another block. Again, this guy invests the same amount. Okay. And all these people have only this much money and all this has. So again, this person again gets the same opportunity. Yes. So what keeps happening?
The same person is adding the
Same
money.
person, which means it is a simple concept that the rich will get richer. Okay, if you have more money, then you can keep locking it up and you are going to again get money after you mine your block. So the more money you have, the more money you can make. That is the concept which can happen in your proof of work here. I mean, in your proof of stake. This is one problem which can happen in your proof of stake. But also there are a lot of mechanisms to kind of evaluate. So what can happen is there are a lot of what do you say, different types of attacks can happen here. I'll talk about that later on. But one thing that can actually happen here is supposing this guy is investing 1,000 ethers and he has started to mine the block, okay, and he's going to add a new block. So he can add any kind of transactions into this block. These transactions that he is adding into the block may be invalid transactions also. If this Bob is a traitor, if he is not a trustworthy person, he has the opportunity to kind of add a lot of invalid transactions into the block. This is one issue. Another one issue which can exist in your proof of stake. But of course, we have a lot of mechanisms which is going to prevent all this. I'll be talking about all that. But I'm generally telling you these are the problems which can happen in this kind of an environment. One, the more number of ethers you have, you can successfully keep on continuously mining blocks one after the other. You'll be given the opportunity. Secondly, since you are the richest amongst all the validators here, you have the privilege to add any kind of transaction into your block. Nobody to kind of question you because you are the sole authority to kind of adding a block. So he can forge in a lot of invalid transactions into it. Okay, so this is another problem that can kind of exist. So but there are mechanisms by which the entire network will detect if there are some fraudulent transactions. If at all a fraudulent transaction has been identified in a block, the validator of the block will be entirely removed from the network, and how much ever he has staked, he'll be penalized for it. Whatever amount he has staked, that amount will not be returned back to him. So that kind of algorithms also do exist in the proof of stake. So this proof of stake is, although it has got a lot of problems, it also has a lot of solutions. Fine, we will be talking about all that also in little much more in detail. Okay, so similarly, when you are actually selecting when a validator is being chosen, there are a lot of things which has to be kept in mind. Okay, one is the reputation of the person. He should not be invalidated. You should actually, the blockchain has to check the history of the entire of the validator, how long he's been validating, how long he's been there in the network, how many how many times he's not been penalized. All these things has to be kind of what do you say, verified initially before you choose the correct validator. So a lot of factors you have to keep in mind to kind of what do you say, start thing it. And this money that I told you that each of these people invest, all these validators will invest the money. Now they will not be able to withdraw that money at any point of time. There is a certain point of time in the network when they can kind of withdraw that money. Only then you can withdraw. Now, for example, in the case of the Ethereum network, what happens is now Ethereum has two versions, okay? Ethereum 1.0, which was working on the proof of work, okay? And now we have Ethereum 2.0 also, which is running. This is working on the proof of stake, okay? So as I told you, 90% of the Ethereum network has already been converted to proof of stake. By 2022, the entire network, 100% of the Ethereum network is going to be converted to proof of stake algorithm. So there is a transition that is happening from Ethereum 1.0 to Ethereum 2.0. Fine. So this transition is what is called as docking. So these validators, how much ever money they have invested, how many ever ethers they have invested, they will be able to withdraw that ether only after the docking process is complete, which means only after Ethereum 1 is completely transformed to Ethereum 2.0, only then they will be able to withdraw their ethers. Okay, so every blockchain which is adopting the proof of stake algorithm or the consensus have certain time period when they can kind of withdraw the ethers. Okay, in Ethereum it is like this. Since we'll be learning about the Ethereum and we're going to work on the Ethereum platform, I am explaining to you only about the Ethereum blockchain. Clear? So only after the docking process is over, the validators will be able to get back the money that they have locked up. Right? Okay. So, so if you want to become a validator, you should see that the amount that you are investing is going to be long term. You cannot withdraw it at any point of time. Fine. And Ethereum also has fixed that the maximum ethers that can be invested has to be 32 or less than 32. Okay, it cannot be more than 32. 32 ethers is the maximum number of ethers that you can do as a investment. Okay. So as I told you, if there is any, if the validator is going to be a traitor or he's going to kind of add a lot of fraud, invalid transactions, there are mechanisms in the network to kind of penalize the entire ethers that that validator has invested. Okay, so instead of people doing it, we also have exchanges. We've come across a lot of exchanges, right? You have a lot of exchanges also who do who help to do proof of stake. And whenever you're investing in an exchange, these exchanges will allow you to kind of withdraw your ethers even before the docking process is complete. Okay, so just some kind of an intermediary which we have, wherein you can start doing your proof of stake through exchanges also. Right? Okay, so yeah, this is the mining farm that I was talking about in your proof of work, right? So you just see the amount of ASICs which is there. Each of this is an ASIC. This is an original picture, okay? So each of this is a ASIC. I'm talking about proof of work now. So unless and until you invest this much, you will not be able to mine or add a block in just 10 minutes. If you want to add one block, every block is added in the Bitcoin network. Every block gets added. One block is added every 10 minutes. Okay. If you want to add a block in 10 minutes, then you definitely must have a mining farm which is this big. Only then you will be able to successfully become a miner. Okay. So this is just a picture I came across about a mining farm. So yeah, this is the proof of stake that what I was explaining. You have a lot of validators, right? All of these people are validators. Okay, the person who has the highest amount, okay, the more number of ethers, that person is given the opportunity to add the block to the network. Okay, so this is the process of proof of stake. So yeah, this is something which shows about the hash rate, I guess. Just a minute, let me just look into what this is. Okay, this is based on the hash rate and the stake. Okay. This also, like, you know, basically shows you about the various candidates. These are the various candidates which we have. Candidates matlab the validators. Okay, so each one of them will have a particular hash rate. Matlab hash rate will also be almost equal to the amount of ethers that they are kind of investing. So the amount of ethers, this is 33%. This guy has got 27, 20, 13, and 7. So obviously this person has got the largest stake, and he is going to be given the opportunity to add the new block. Okay, so this is just another diagram which shows the entire process. Okay, this will come to in some time. So before that, something more I wanted to tell you here. Yeah, one thing that I just wanted to add on in proof of stake is in the proof of stake, you know, there are certain measurements. So 12 seconds is considered to be one slot. Okay, like in the Bitcoin network, I told you that every 10 minutes, one block will be added. And we also told you about how many nonces can be generated every second. Okay, so 40 seconds it will take for you to kind of generate all the 4 billion nonces. So similarly here, one slot is actually called as 12 seconds. Okay, so to add a block, one block is added in one slot. In one slot, one block gets added. Fine. So, and like this, you can have 32 slots. Okay, 32 slots, which means 32 blocks are being added. Okay, once 32 blocks are over, it is going to be called an epoch. Okay, so which means after I add 32 blocks like this, 32, assume there are 32 here. Okay, 32 blocks. After adding 32 blocks, this one period here is called as a epoch here. It's called one epoch. 32 slots, I'll write it here again. 32 slots is going to be equal to one epoch. Okay, so in one epoch you can have a set of validators. Okay, you can have around say 7 to 8 validators can be there. After one epoch, all these validators will go away and another new set of validators are chosen. That is how proof of stake works. Okay, so every epoch or every 32, after adding 32 blocks, a new set of validators will be chosen from the pool and then they will be allowed to kind of compete amongst one another. Fine. So this is what a little bit of mathematics that happened in choosing the validators for adding the block in your proof of stake. Fine. Any clarifications you require here? We'll just do a comparison between proof of work, proof of stake, and then go on to the next consensus algorithm. Proof of work and proof of stake. Any clarifications you need, guys? You can just tell me. Otherwise, I'll just continue.
Proof of work, we are using an algorithm like hashing a function and all. And in the proof of stake, we are selecting who is going to add the block. So how will be the method in the proof?
No hashing. There's no hashing at all. Now this person now in this diagram here. Say this is some person. Okay, now she has got the opportunity to add the block. So what she will do is she'll go to the mempool. She will choose a lot of transactions will be there in the mempool. She'll just take in some 100 different transactions. She'll put it here. Then she'll take the previous hash. She'll add the previous hash. Then she'll calculate the hash of this entire thing, that is the Merkle tree, etc. Merkle root will all be calculated. The block hash will be calculated. The previous transaction hash is added. After computing the headers, directly this block gets added to the chain. That's all, finished. There is no what do you say, validation to kind of authorization or validation, validity. Nothing has been there in proof of stake. That is why it is very what do you say, it doesn't consume that much energy and cost. It is easier, it is much easier than proof of work. That is why I told you this validator, when you're choosing the validator, this person has to be very reliable. Okay, there are a lot of I'll tell you what all attacks are possible. I'm discussing that next. A lot of possible attacks are there if this validator is going to be a traitor. There is a lot of things that can happen. The entire blockchain can get corrupted. That can happen. So the validator who is going to be chosen should be the right person. Only then this, and that's what I'm telling you. This is what is called as a consensus. Only if all these people agree to a certain, only if suppose if this person is adding a block, this person or a company or whatever this is, she has to be a person who is kind of following all the protocols of this blockchain, because the moment she is penalized and she's removed from the network, she will not be able to make any more money on the blockchain network. Okay, so most probably you will only find trustworthy people in your proof of stake. You cannot find untrustworthy people, because those people, the moment they have been identified, they'll be removed from the network and they're going to be penalized heavily. Okay, it is not that they'll be just deprived of the ethers, but they're legally kind of what do you say, penalized. So it is all the validators are just, I don't think validators will just come around to play. They will definitely, they are coming here to make money. The intention is to make money. So make money in the right way. Okay, so here there is now nothing of proof of work kind of algorithms are not necessary here. You can just add easy. Adding a block is very easy. The moment you win, you add the block. Finished. Okay. Yeah. So comparing proof of work, proof of stake, you can give a lot of comparisons. Okay, I'm just generally telling you here. Of course, energy is more energy consumption in terms of energy consumption in terms of your electricity consumption in proof of work. That's that is what I mean by telling energy consumption. Okay. So electricity consumption now, what is being estimated is in proof of work, the amount of energy that is generated by the ASIC. Equipments, it is enough to kind of light up an entire country of, say, New Zealand. That much electricity is consumed in your proof of work just to do a mining process. So just imagine the amount of, if individuals can definitely not even imagine to do proof of work kind of mining process. So it has to be a mining farm of big companies which can do it. So the amount of electricity is equal to the amount of electricity that is required to kind of light up the entire one single country. This is of course a small country for one day. One day, how much of a consumption New Zealand takes, that much of electricity is consumed in your proof of work. Okay, so energy consumption is very high. Here, there's nothing, absolutely nothing in proof of stake. It's much, very, very, very less. And here, what else do we have? Yeah, another thing here in proof of work, what happens is the transactions in the block can keep changing. Okay, there is a possibility here. Here, there is that option does not exist in proof of stake. You can add any transaction. There is no possibility. You need not kind of remove transactions from a block, add new transactions. All that is not required. And here, investment is very, very high. Okay, high investments. Your investment costs are very, very low. Okay. So these are a few differences that we can basically tell between proof of work and proof of stake. And both of them are equally secure. In security and all, there's no compromise at all. They are definitely secure. I'll discuss about proof of stake problems and solutions now. So they're equally secure, equally trustworthy, and reliable. Okay. All right. Okay. So just go on to tell you about some attacks which basically exist. Okay. Well, one attack that we have to learn is what is called as a Sybil attack. Now, these kind of attacks that I am explaining now can exist on any kind of a network. It can even happen on a proof of work network. Okay, more prone on a proof of stake network. Okay, so Sybil attack is one thing. So Sybil attack, it was an attack which was found out by Microsoft at one point of time. The history actually goes to 1973. There was how this name came into existence. That's what I'm telling you. So there was basically a lady who was actually called as Sybil Dorset. Okay, so this Sybil Dorset had this problem of, sorry, hope you've heard about this. Heard about this? Yes.
Yes,
Are you able to see what I wrote?
yes, ma'am.
Huh. What is this problem? It's a common, general question. Nothing to do with anything technical. It's called multiple personality disorder. Everyone knows what it is?
A person behaving like a other person in a certain time.
Yeah. Person behaving like many other people. Okay, 2-3 different people at different instances of time. That is what is the MPD issue. Okay, so there was a this kind of a person existed, and from this only they coined the term called as Sybil attack. Okay, so how do you relate it here? How would you relate it on forget blockchain network, anything over on a computer system, you can say, for example, on a website or on a network, on the internet. How will you relate this onto the internet? Simple.
Like
Huh.
behaving like one person, people will think
One person.
actually ABC.
Come again.
Behaving like other person, like I am actually XYZ, but I am behaving like ABC. So
Exactly.
people
Where will it happen? How? Where will this happen?
in social
Example.
media,
Right.
it can
So what is
happen.
that called? What is that? You're creating what? On a social media, you're creating, say, Facebook. You're
Clone,
creating what? What are you creating?
clone, right?
Okay. In simpler,
Fake
in simple
identity.
words, it is a fake account, right? So you are somebody, but you could pose yourself to be somebody else on a social media page. Okay, any social media page if you take. Okay, I also like examples of a lot of fake reviews that is there on all your online websites, whatever you purchase, right? So matlab, I now supposing I work on Amazon and I am kind of responsible for the better outreach of all the products and services that they offer. So what I can do is I'll have a lot of people who can ask them to create hundreds and thousands of mail IDs. Okay, and from each of the mail IDs I will ask them to write good reviews for different products. Okay, I can increase the rating, I can increase the visibility. All these things are possible from a company's point of view. I can have hundreds and thousands of accounts created. I can make people write a lot of good reviews for certain products and increase my market value and my selling, right? This is also possible. So these are all general things which even exist even today on the websites. But to find out all this, there are a lot of tools which is available now on the various platforms. You have a lot of extensions, browser extensions, like what do you say, you have fakespot.com, you have review meta. All these all these websites enable you to kind of identify the fake reviews, which review is right, which review is not right, which is supposing you have one product on Amazon is all store, or everything is storing 5 star, okay, or 4 plus star, 4.5 stars, around 10 reviews which has got only 4.4. The entire rating on an average of the product is going to be 4.5, right? So you cannot just blindly tell, acha 4.5 rating is fine, let's go buy it. No, don't go for it. You have to go find out whether the review that has been written is right or wrong, whether it is valid, trustworthy or not. So you have a lot of tools which you can install, a lot of extensions are available, but I commonly use FakeSpot. Okay, it gives you a it will also give, supposing Amazon may a product ka review shows as 4.5. Now if I go to FakeSpot, it will show me a review of only 1.5, which is right. They also run a lot of algorithms to kind of find out which review is valid, which review is fake, and they also kind of create a parameter and display it to you. Okay, so these solutions are available on the it's all available for us online. So similarly, over a blockchain network also, this is possible. Creating several accounts, one person at the network, or one miner in the network, or one validator on the network can set up several other nodes on the network, and they can kind of start capturing the entire network. So that is basically what is called as a Sybil attack. Okay. Now I'll just explain to you one kind of Sybil attack, just very, very essential on a blockchain network, just called as a 51% attack. Okay. So Sybil attack is just this. So when coming to Sybil attack, you just have one person. So I have one miner, say for example, I have around 5 to 6 miners. Okay. So this is miner 1, 2, 3, 4. Okay. Now this third miner, what he can do is he'll set up this third miner can nodes. He's setting up around 10, 12 different nodes he's setting up. Okay, so what will happen is this person, this miner 3, he's setting up a lot of fake nodes on the network so that he captures the entire network. He is going to have maximum coverage of the entire network, so he has the power to do anything over the network. Fine. This kind of attack is what we call as Sybil attack. So this is exactly what happens in something called as the 51% attack. 51% attack was identified in proof of work initially. Okay, so what happens in a 51% attack is, I think I have the slides. Let me just see if I have the slides. Yeah, delegated proof of stake. I'll come to this later then. So just going to talk about 51% attack. Okay. So what happened? Yeah. Yes. Somebody interrupted. Any problem?
No, ma'am.
Okay. Okay. So so here what happens is anything that you can find out from this, what is happening? What's the time? Yes. Anything that you can identify from this this entire process that you get to see on your screen?
He's adding the wrong branch into.
So what basically happened is there are two branches you can see of the blockchain. Okay, there are two branches from block 39 onwards. The blue one that you see is the valid set of people. Okay, and this red person that you see is an invalid guy. Okay, so if this invalid guy is actually adding a lot of invalid blocks over the network, and he will capture the, if there are a large number of such invalid people on the network, the eventually this block will keep on, this blockchain increases, this red one blockchain increases in number, and finally what happens is even the valid ones, valid miners will come and start following the invalid blockchain. That can happen. This is what is basically called as a 51% attack. I'll just explain to you in detail what will happen. Okay, now so when one miner has got a large mining capability, okay, which is more than half of the existing Bitcoin network, in that case he will be able to have more power. He has more power to kind of add more blocks onto the network, because supposing now, as I told you, this is simple as, like now I have I have a miner A, I have miner B, C, and D. Okay, four miners. Now D is going to be a malicious guy who wants to kind of do a lot of invalid activity. So what he will do is he set up a lot of fake accounts, like say so D1 he will do, he'll set up D2, he'll set up another account like D3, and like this he's going to set up a lot of nodes. Okay, a lot of nodes he will set up, say D5, and then like this D6 and D10. So around, so the entire network, if you see, is going to be dominated by this miner who is called as D. All the other nodes in the network are D. So what happens? The computational power of these people is going to be very high. All these people will jointly compute, and jointly they will kind of try to find out the next hash. I'm talking about the proof of work algorithm here. Okay, so this computational power of D is going to be very high, and they are always going to be successful in adding the blocks to the blockchain when compared to the other miners in the network. Okay, so when you have one miner who has occupied almost 50, more than 50%, okay, or at least 51% of the network, if this miner has occupied, then he only has control over the entire network. He becomes one single authority to control, wherein Generally, in a blockchain network, you're not supposed to be having a central authority. Okay, this should not be there. So this kind of possibility that we have is what is called as Sybil attack and 51% attack. They're not exactly the same. 51% attack is a kind of Sybil attack. Okay, one type variant of Sybil attack. Fine. Now I'll just explain in detail as to what can happen here. So fine here. First, what happens? These are my truthful miners. Truthful set of miners who are like adding blocks to the blockchain. Okay. Now 38 was there. They've added 39. They've added 40. They've added 41, and they've added 42. Okay. Now this is a malicious miner. Okay. He also has got control over the network, but what he is doing is he has also added 39, 40, 41, but this he has created a private chain. He has not broadcasted it. He has created it on his node, on his local node, okay, wherever he is working. He has created a private chain wherein he's got 39, which is different from this. These two blocks are different. All these blocks are different. This is the right blocks, okay? These are the invalid blocks. So he has like added 39, he's added 40, he's added 41 also. Clear? Now see what happens next. Fine. So assume in this situation, what can happen is, I'll come back here. Here, what can happen is a transaction can be reversed in such a kind of a situation. I'll show you how a transaction can be reversed. When I have a 51% attack. Why we have 51% attack? The drawbacks of having a 51% attack is transactions can be reversed in a 51% attack. How it is done, we shall see now. So this is a two set of people we have over the network. One who is broadcasting it. Okay, the original network is there, truthful miners who are adding the correct blocks, and this guy is adding a lot of illegal blocks and just private. He's not broadcasted it. He's not publicly broadcasted to the network. He is having it privately in his own PC. Okay. Now we'll see how a transaction can be reversed. Now a malicious miner, what this guy will do is, supposing say he has a transaction. This is one transaction of this person. He has spent 100 bitcoins to purchase something. Okay. In this case, they are assuming it to be a luxurious car. And this is a transaction which the miner has added. He has broadcasted it to the network, okay, and it has got added to the network and it is there in the blockchain. Okay, now this is a transaction which the malicious miner has created, wherein he has spent 100 bitcoins and he has put it in the public chain. This is the public chain. This is the public chain. Okay, this is the private chain. Now in the public chain, there is a transaction which says that this person, I give them a name. So this is, I'll call them David. This is a name which commonly comes to me. So David is a malicious miner. Okay, it's a malicious miner. He has created a transaction of 100 bitcoins in the valid chain, the valid public chain. Okay, he's got it here. Now what this guy can do is, in his private network, he will change the transaction amount to 0 and he will store it. This is his private network. In the public network, which is broadcasted, okay, this is my Bitcoin network. In the Bitcoin network, it shows that he has spent 100 Bitcoins. But in his private network, he modifies it, the transaction, and puts 0 there. Transaction amount, he's changing it to 0 and he's building this chain. This chain is being built. Okay, so now more and more blocks this guy is kind of adding onto the network. Fine. So that's what this says. The malicious miner spends his Bitcoin on the truthful public chain on a luxurious car. Meanwhile, the malicious miner does not add this transaction to his private blockchain. The private blockchain is not adding it. Okay. So as per the private blockchain, he still has 100 BTC with him as per this blockchain. In this chain, as per this blockchain, 100 BTC has been deducted from him. Okay. Now see what happens next. So now the truthful miners are adding the blocks to the blockchain. Okay. But at a slower pace. Why at a slower pace? Because this malicious miner has got higher equipments. He's got larger number of ASICs. He's captured 51% of the network. He's got more miners working. So he has captured almost the entire network and he's mining blocks. So he will definitely mine blocks at a faster rate, which means he'll be adding more and more blocks at a faster amount than compared to your truthful miners, then compared to these people. Okay, so now this guy's blockchain will keep on increasing. It will become bigger and bigger and bigger. Fine. So the malicious miner is adding blocks to this private blockchain faster. And then what happens at one point of time, once this chain, this private blockchain becomes longer than the public blockchain, this guy will broadcast this entire chain that he has built onto the network. He's going to broadcast this to the network. So what happens? All these truthful people will get to see this blockchain, which is lengthier. So any miner, when he is adding a block to a blockchain, the bigger, whichever blockchain is bigger, only to that he can add blocks. That is the rule on a blockchain network. Fine. The length, the blockchain which is more lengthier or bigger in number, only to that chain the blocks will get added more and more. I think we have seen this in the fourth concept. In the concept of forking, I think I have kind of explained about this. So what happens? This blockchain will get broadcasted and these people will now start adding the new blocks. These people will migrate here and start adding blocks here because this is the lengthier blockchain. Fine. This is done. These people will join this network and they will also start adding all the right blocks here. The forthcoming blocks, everything. Now this had. Now what will happen? Now this entire block will get truncated. It is gone. It is gone. It is no more considered to be valid. All these transactions here is no more considered to be valid. So what happens? This 100 bitcoins that this person has spent is going to be considered invalid, and this transaction where he has spent 0 bitcoins is going to be valid. So what is this guy done? Eventually, he has reversed the entire transactions of 100 bitcoins which he has used to purchase something. So the entire transaction has been reversed. This is this is what is called as a 51% attack. So now this guy has got the entire control of the network and he can do this any number of times over the network. Is this clear to you all?
Yes, ma'am.
Right, this is a very, very important concept, very very commonly asked question. It could be a commonly asked question even on an interview perspective. What is 51% attack? On a 51% attack, one particular miner gains control over more than 50% of the network and he has the power to add invalid transactions as well as reverse the existing transactions. How he can reverse the transaction is what I just showed you in this diagram. Okay, so you had a valid chain, invalid chain. Invalid chain may he has modified the transactions. At one point of time, the invalid chain gets converted and becomes the valid chain, which everybody will start migrating and everybody will start building on it. Okay, so this is what is called as a 51% attack. So such kind of attacks has happened several times in the blockchain network in the year 2018. There was a company called Verge. Okay, and so from this Bitcoin company, almost around 250,000 Bitcoins were stolen. Now in this case, this guy has stolen 100 Bitcoins only. Okay, so there was this many Bitcoins which were lost. And similarly, I told you about one forking process where in 2018, Bitcoin Gold was created, right? In Bitcoin Gold, when they were created, $18 million. 18 million matlab, 1 million is actually 7 crores. Okay, so 18 million matlab that roughly around say 135 crores were stolen on the Bitcoin Gold network. Okay, and similarly 2020 May, since Ethereum also started adopting, Ethereum also initially was working on the proof of work, right? In 2020, Ethereum also underwent a similar kind of 51% attack where $5.6 million were lost. So these are all a few examples of bitcoins being lost in the network due to this attack. Okay. Now, this is something which can happen, but in a proof of work network, this in a proof of stake network, 51% attack is possible. In a proof of work network, this cannot be possible. Why? Because you cannot have one miner who is going to occupy 51% of the network. Now, the network itself is going to have millions of users. Okay. Now, if one person or one company has to occupy 51% of the entire network, he must be a ultimate billionaire. Only then he will be able to invest that much amount of money or that much amount of money investments on the equipments to kind of start mining process. Okay, so utna money nobody is going to invest for a proof of work network because it is very, very costly. Okay, so proof of work may 51% is completely eradicated. It does not exist at all. Okay, it is not possible to kind of exist. But in proof of work systems, there is a chance for proof of, this 51 percentage attacks. So, what solution? One solution that the proof of stake people suggest is, now in this case, this example that we saw, this here this broadcasting, right? Now this person is actually broadcasting this entire network after a certain point of time. He's added around 4 or 5 blocks, and only then he's broadcasting it onto the network, onto the public network. This has to be avoided. You cannot broadcast a block after a certain period of time. You have to, or late submissions. In other words, late submissions of blocks are not allowed on a proof of stake network. The moment a proof of work is, moment a block has been created, immediately it has to be added onto the network. Late submissions are not allowed on a proof of stake network. Okay, that is one way in which this Sybil attacks and 51% attacks are overcome in your proof of stake. Okay, so that's about proof of stake. I have a couple of more to finish. I don't think I'll be able to complete them. I'll probably do that next class. I think there was a small present. Nitin is here.
Yes, ma'am.
Nitin, तो आपका डेट आज था ना 18th ना cryptocurrency का. Fine, will you go ahead with it?
Yes, ma'am.
Right, and let me just remind you, the next two people are Ashutosh and Sachin. Are you guys there? Sachin and Ashutosh, you will do it next Monday. You need to be ready, okay?
Yes, ma'am.
Because this week we will not be meeting again. Only for the lab we'll meet. Apart from that, we'll again meet next month. Tomorrow we won't have a class, right? Because I think it's a declared holiday. So Nitin, go ahead.
Ma'am, presentation.
Yeah, 1 minute, 1 minute, 1 minute. Yeah.
Ma'am, my screen is visible?
Yeah.
Hello everyone, this is Nitin Naik. Today I'm going to discuss about the cryptocurrencies. What is cryptocurrency and its types and some of the popular cryptocurrencies. So first we can start with what is understanding what is cryptocurrency. Cryptocurrency can be defined as a virtual or digital money that takes the form of a token or a coin which exists on a distributed and decentralized ledger called a blockchain. So by reading this definition, we can correlate with our traditional money also, because that money also available virtually through our internet banking and all. So what is the key difference between these two currencies? So let's find out the difference. The in the traditional currency, physical embodiment is possible. So at any point of time, we can go to ATM and we can withdraw money in the physical form. But in case of cryptocurrency, we can't do that. We can convert the cryptocurrency in any other traditional currency format and withdraw it. The ATM, the Bitcoin ATMs are available in the western side, but we cannot embodiment the physical form of a Bitcoin or a cryptocurrency. The second difference is centralized and decentralized. In the traditional currency, the bank and government monitor, control, and govern the whole cycle. But in case of cryptocurrency, it is decentralized. Like any, it is not. It does not comes under a single authority. So, in case. In case in the centralized, if bank's server gets down, the whole system gets affected. But in decentralized, if any node gets down, but there are still many nodes which can back up the entire process. The limit on purchase and withdrawals. In the traditional form, there is a limit on purchase and withdrawal, but in case of cryptocurrencies, there is no limit as such. uh, ne- uh, in order to create a bank account, we need some paperwork, but there is no um, uh, data hiding. Like in case of cryptocurrency, we can be anonymous and do the our work. um, with no paperwork, we can start our cryptocurrency account. International transactions are slow, but in case of cryptocurrency, international transactions are fast. um, the cost also in the traditional way, we there are some charges like we have when we want to do international transfers and all, there are some additional charges. But in case of cryptocurrency, all the transaction cost same, or no charges will be there. So these are some differences between traditional modern currency and cryptocurrency. So we can in we can there will be a doubt, like if this is this much profitable, then what is the security behind it? So cryptocurrency is backed by the blockchain. The backbone of the cryptocurrency is blockchain, which use cryptography as a mechanism. So the name cryptocurrency come from there. So in this slide, we can briefly understand the working of blockchain. It use cryptocurrency it use cryptography, SHA 256 algorithm, and public key and private key. The public, in the analogy, we can understand public key as our Instagram ID name and private key as a password of that account. So when we create a digital wallet in for any cryptocurrency, we get a public key which we share with others, and a private key which that we keep secret. So this is how the transaction is added in the blockchain. Transaction details like the money and sender and receiver is passed through this algorithm. The the private key of the sender is encrypted with it. Then the digital signature is created. Then it is distributed in throughout the blockchain. So this is how the cryptocurrency works. In the definition, we have seen that cryptocurrency can take a form of a token or coins. So let's understand what does that mean. A cryptocurrency can be termed as a coin or a token. A coin is basically, we can say that a coin has its own blockchain network. So it works on its own blockchain. But in case of token, it works on other systems blockchain network. So for example, Bitcoin and Ethereum works on their own blockchain network. But in case of Tether,
Sure.
USD coins, Uniswap, and Rapid coins, it works on Ethereum network. Um, so the basic difference between coin and network, we can consider we can use coin for trading purposes, also for payment. But in case of tokens, we can use them for payment also and digital contract. for an analogy, if we go in a canteen and we order some food, and he gives a token, so that token represents a value, and we can buy certain things which comes under that value, like for example, XYZ companies bought a 10 ounce of gold, and they created a digital signature like token using indicating that each token will represent a 1 ounce of gold. So anybody buys that token can go out in the market and say that it represented 1 ounce of gold, like. And token does not always say that there is a physical body should be available like gold and all. We can create a digital contract upon some services also, like for example, for a music app, we for the premium version, we should pay some certain amount of money. So in the digital contract we can also contract this service, like if we buy this contract, we can be eligible for this amount this kind of services. So this is the basic difference between coin and a token. So let's dive into the some popular bitcoins, so cryptocurrency available in the market. The first one is Bitcoin. The code for it is BTC. It was introduced in 2008, and it was made public in 2009. The subunit of Bitcoin is uh, one by this much Satoshi. That is represented like that. The hash function used in Bitcoin is SHA-256. The initial release was about 12 years ago, and the latest release was about 34 days ago. Traditional transaction speed is about 10.5 minutes. The Bitcoin value is the current value, like all the amount is 46 for 4 lakh 67,000 46 lakh 77,009 rupees. The market capitalization is 81 billion US dollars as of now. The second cryptocurrency is Litecoin. It is derived from Bitcoin only, but it uses a different hash function, like that is script. It was made public in 2011. The latest version was released about 16 months ago. The transaction speed is much more faster than the Bitcoin, that is 2.5 minutes. The one Litecoin is around 13,000 rupees in the market right now. The market capitalization is around 12 billion US dollars. The third is Monero. The code for is XMR. It the hash function it uses is random x, and the transaction speed is faster than Litecoin, that is 2 minutes. The one macro is around 20,000 rupees, and market capitalization is around this much billion dollars. Thank you.
Okay, fine. Okay, I've taken your attendance also. Only 9 of you all are there, right? 7. Just generally call out. Asan,
Yes, ma'am. Present.
Arun,
Present, ma'am.
Ashutosh,
Present, ma'am.
Athar,
Present, ma'am.
Bhagwat,
Present, ma'am.
Fardeen,
Present, ma'am.
Gautam,
Present, ma'am.
Nitin,
Present, ma'am.
Sachin, right? Only this many people. Okay.
Yes, ma'am.
All right. So meet you on Wednesday for the lab. All right. Chalo, bye.
Bye, ma'am.
Yeah.
Bye, ma'am.
Bye bye.
Bye, ma'am. Bye, ma'am.
Bye bye.